welcome back to Mind and Maths with Amina. In today's lesson, we're going to continue solving questions which are given in the chapter 2 called Basics of the EMFSS study guide given by University of London. The course is called Mathematics 1 and this is the chapter 2. Okay, let's begin. Suppose the market demand function is given as follows. So price is a function of quantity is 4 minus q square, and the supply as a function of quantity is 1 plus 4q plus q square. It wants us to find the equilibrium price and quantity. Therefore, we need to solve it simultaneously. Okay, so I'm just going to plug equation 1 into equation 2 to obtain 4 minus q square is equals to 1 plus 4q plus q square. Therefore, I have a 2q square plus a 5q minus a 3 is equals to a 0. Let's use the quadratic formula, which is a minus b plus minus b square, which is going to be a 25, minus 4ac over 2a. Therefore, I have a minus 5 plus minus a 25 plus 4 2s are 3 2s are 6 and 6 4s are 24. 2 2s are 4, and therefore we have an under root of a 49. We know 7 7s are 49, so we get a minus 5 plus minus 7 over a 4. Therefore, remember, we are not allowed to have negative quantities, right? It's not possible to sell a negative quantity of any good. So the only viable solution is a minus 5 plus 7 over a 4, which is 2 over a 4, which is half. Even this is kind of like a funny solution because it's like saying I'm selling you half of a car. But in economics, we basically are making this assumption that even you can sell goods in even decimal places. Otherwise, even our consumer surplus wouldn't be this whole shaded region if we didn't make this assumption. Anyhow, and what would be the equilibrium price? We can plug it into any equation given. So let's put it in 1 plus 4q plus q square. We have a 1 plus 4 into a half plus 2 square is a 4. So I have a 4 plus 4 2s are 8 plus 1 over a 4. 9 plus 4 is a 13 over a 4. And that's it. We're done with the first practice question. Let's move on to the second question. Suppose the demand relationship for a product is this and the quantity supplied is this. Determine the equilibrium price and quantity. Again, they're giving you a question in which you have to solve two equations simultaneously. We know an equilibrium quantity demanded is equals to quantity supplied. So, and therefore, the price demanded is equals to the price supplied. It's the same thing. Okay. When we equate these, I'm going to get a 6 over a q plus 1 is equals to q plus 2. After cross multiplying, I have a q plus 2, q plus 1, and therefore q square plus plus q plus 2q is a 3q plus a q, 2 is equals to a 6, q square plus 3. And then we have a minus 4 here is equal to 0. We can factorize it, but we don't need to use the quadratic formula because the roots are pretty like easy to see. We have a 4 ones are 4, so 4 minus 1 will be a 3. So if I take a q common, I have a q plus a 4, and I want a q plus 4 again, therefore I have to take minus 1 out. And if I take q plus 4 common, I have q from the first expression and minus 1 from the second one. And therefore I have two answers, q is equals to minus 4 and q is equals to 1. And since this is the positive answer, that's the only solution that will make sense. Let's find the corresponding price. The price is equals to q plus 2, q plus 2. So the equilibrium price is going to be a 3. So equilibrium quantity is a 1 and equilibrium price is a 3. Okay, moving on to the last question given for you to practice. They're asking us, they've given us the demand equation, which is q minus 8 is equals to 8 minus p square minus 2p. And they've given us the supply, and they're asking you to sketch on the same diagram, and they want us to determine the equilibrium price. Okay, so let's draw the demand function first. Okay, remember step 1 was to find the intercepts. Okay, let's find the intercept. When you take p is equals to 0, you're going to get a q is equals to an 8. So if we have p on the horizontal axis, since actually they've represented q in terms of p, so it's kind of like an indication to put q on the vertical axis and p on the horizontal axis, because they've represented the function like this. Okay, so the demand equation is given and we're drawing this first. Okay, so we have one intercept as this. Okay, moving forward, when we have q is equals to 0, you have 8 minus p square minus 2p is equals to a 0, which is a p square plus 2p minus 8 is equals to a 0. So 4 2s are 8, right? So we can factorize this instead of using the quadratic formula. 4p minus 2p, 4 2s are 8, and we get 4 minus 2 is a 2. So it's easy enough to factorize. P plus 4, take a minus 2, p plus 4 is equals to a 0. So we have a p minus 2, p plus 4 is equals to 0. So price is equals to either a 2 or a minus 4. So we have more intercepts where p is equals to 0, q is p is equals to 2, q is equals to 0, or either p is equals to minus 4 and q is equals to a 0. Okay, the next step now is to find the critical points, which in this chapter we are going to find using the completing square method, and we won't use the derivative. Okay, so let's write the equation. The equation is this. Okay, first I'm going to take minus 1 out as common, so I'll have a p square plus 2p minus an 8. 2 divided by 2 is a 1, so that tells me that I need to plus 1 square and minus 1 square from this, because I'm completing the square. And then I have the expression p plus 1 whole square, and a minus 1 minus 8 is simply a minus 9. when I open this bracket up, I have a -1, which indicates actually a maximum point, and I have a p plus 1 square plus a 9. So we have a -1, which is less than 0, which tells us that we have a maximum point, and the point itself is p is equals to a -1 and q is equals to a 9. So since we have a q on the q on the vertical axis, so this is going to be a -1 and a 9. Okay, so before we actually, let's just draw this on the next page. Let's add a graph paper, and let's start drawing this. We have it goes like the vertical axis is going up till a 9, so 1, 2, 3, 4, 5, 6, 7, 8, 9. Okay, and this is the quantity. Prices were going till around a 3, so 1, 2, 3, 4, and a -1. Even though this is not the negative axis is not relevant to us, but I'm still going to draw it so that we have an accurate depiction of these. Okay, so the intercepts, okay, a 0 and an 8. Okay, so the first point comes here. The x-intercepts are 2, 0, -4, 0, 2, 0, a -4, 0, and the vertex is a -1 and 9. Okay, -1 and 9. So we have a curve that potentially looks like this, and I'll try to tidy it up, but oh, wow, perfection, beautiful. So I'm going to label this as actually this was quantity demanded in terms of price, and the part of the demand curve which is relevant to our analysis is this part. Okay, so sketching the supply curve. So second part is the supply function, and for that, again, we're going to follow the same procedure, which is that first we're going to find the intercepts. So step 1 is always the intercepts. Okay, so the equation was p square plus 2p minus a 3. P square minus 2p minus a 3. Let's confirm. Plus 2p minus a 3. So when p is equals to a 0, q is equals to a -3. So we have a 0 and -3. And when q is equals to 0, we get a p square plus 2p minus 3 is equals to 0. So we have a 3p minus a p, because 3 ones are 3 and 3 minus 1 gives us a 2. And now we have a p plus 3 minus 1, p plus 3, and then we have a p minus 1, p plus 3 is equals to a 0. So p is equals to a 1 and p is equals to -3. So we have a 1, 0 and -3 and 0. Now the vertex, the step 2, is the critical point and its classification of the critical point. So we're going to use the completing square method. Let's do that. Since we have a 2, we're going to simply plus 1 square minus 1 square minus 3. So we have a p plus 1 square minus a 4. So the vertex is a minus 1 and minus 4. And since the coefficient is positive, so since 1 is greater than 0, this is actually a minimum point. So now we can draw all of this. Okay, vertex minus 1 and minus 4. Vertex minus 1, minus 4. Okay, it comes here. The intercept is minus 3, the y-intercept. The x-intercepts is 1, 0, minus 3, 0. So 1, 0 and minus 3, 0. Okay, and when we connect this, nope. See, I was lucky the first time. I knew it. And let's try to make this go in exactly all the places that I want them to go. Okay, so the point of intersection is this. So like 1.5 and 2.5, but obviously I will need to like solve this simultaneously to get the exact value of the point of intersection. So I just need to solve these simultaneously. So that would be a p 8 minus p square minus 2p will be equals to a p square plus 2p minus a 3. Okay, so let's solve that simultaneously. Minus 3, we'll get a 2p square plus a 4p minus an 11 is equals to a 0. So p is equals to minus b plus minus a b square. So it's a 4 square minus 4ac over a 2a. And therefore we have a minus 4 plus minus 4 4s are 16 minus 8 into an 11, so a plus 88 over a 4. So we have a minus 1 plus minus under root of 104 over a 4. And we can actually just use a calculator at this point. So actually let me take out my calculator. Under root of 104. Okay, the under root of 104 is a 10.198. So let's just take it as a 10.2. So if I divide it by a 4, I have a 2.55. So let's just write a 2.6. So p is equals to we have two values, minus 3.55, or it's going to be 2.6 minus 1, 1.5. So yeah, this is the 1.5 I was referring to, and the other point of intersection is actually right here, somewhere over here, and it says minus the, oh, very nice actually, diagram is pretty accurate, minus 3.55. And we can easily find the corresponding values of quantity by putting it in the in any of these, either the demand or the supply functions. Okay, so we've solved the question sample. No, this wasn't the sample examination questions. These were the practice questions. So we've solved these, and in part 4 of this series I'll solve the sample examination questions given in the studied guide. So this is enough for now. Take care and be kind to yourself.